your feedback. And I think the most important thing that we want to highlight that we want out of the task force is ongoing collaboration. That's been sort of an issue in the past from the research side. We identify risk reduction options for buildings without necessarily collaborating directly with the building industry to identify practical issues. So that's really our intent over the next couple of years, and hopefully coming out at the tail end with some really solid advice that's very well informed by your industry. So really quickly, ICLR, we've been around for about 25, 26 years now. I would categorize our work into three separate areas. So historically, and from the beginning, our focus is on research. So we are an institute at Western University situated within the engineering department. We've had a long-running relationship with the wind engineering group. And since about 2008, there's been a group there led by Professor Greg Kopp that has really focused on Part 9 construction and wind vulnerability. And that's included wind tunnel testing. There's a full-scale testing facility there, and also post-loss on-the-ground site inspections. So they'll go around after every tornado in the country right now, and they will pick up debris and identify vulnerabilities in buildings. Similarly, on basement flood protection, we've had a lab running with University of Guelph for about 7 years now, looking at how different elements of buildings perform under heavy rain loads. And we have similar work going on for wildfire, and I'll talk a little bit more about that later on. Since about 2016, it was really the Pan-Canadian the Pan-Canadian framework on clean growth and climate change that identified the need to adjust codes and standards in Canada for climate resilience. And coming out of that work, we've been really involved with different agencies, NRC, Standards Council, and so on turning the research into usable guidelines. So that means standards and guides and so on. And then bottom left is a few examples of what's come out of that work. We've also worked with municipalities across Canada on these topics. And then really within the last 5 years or so, we've been asked by our board to shift from sort of research and guideline development toward implementation. And we've got a few pilots that we completed, some with developers and builders, some with municipalities, and several with the insurance industry. And I'll talk a bit about that as well. So part of the reason why we're forming the task group for the task force now is that we do have some on-the-ground implementation, and we think we're ready with the input of the building industry and insurance industry to kind of scale this work up. So what we found, so we are largely funded by the P&C insurance industry. What we found from our insurance membership, which represents about 90% of the market in Canada, is that when we have catastrophe events, the majority of losses tend to be accrued to property insurance. So that's basically residential buildings, contents, living expenses, and so on. The remainder for the P&C industry is broken out into commercial and auto. But by and large, the insurers have come to us with questions about reducing risk for residential properties. That's been their primary concern. One issue is, they tend not to be engineered. And of course, older properties are more vulnerable in many ways. But what we see is typically about 60% plus of catastrophe losses. When we see these big catastrophe events, 60% of those losses are to residential properties. So the rest of my presentation, I'm going to talk about what Frank Lohman has advised us to start a discussion with the building members of the task force, and that is on readiness for conducting pilots in these areas. So kind of generating some background information so that we can get to a state where we can conduct pilots and generate useful results from those pilots. So first thing I want to mention is that we're not starting from zero. There are many, largely municipalities in Canada that have been implementing resilience. So the first point here is that there have been several municipalities that have implemented incentive programs. We've worked with Dufferin County in Ontario, and we also worked with City of Calgary throughout 2020 to 2022 on an incentive program for roof cover, for impact-resistant roof cover. And for several decades now, there's been several dozen communities in Canada that have incented basement flood protection. Basement flood protection generally oriented toward existing buildings, but the Dufferin and Calgary programs both included existing and new construction. There's some elements that we'll talk about with the task force over the coming months that are already technically covered in codes, but because of different interpretations locally, they're not applied. And one example of that is the NPC 2464 wording for sewer backflow protection, and that really relates to backwater valve installation for sewer related flooding. So some jurisdictions, they interpret this wording to require backwater valves, others they don't. So the point is that we are applying these measures in some cases, just not universally across the country. City of Barrie, we worked with them after the 2021 tornado to develop a set of code change requests for Ontario and national. Those are still working through the process, but it's another example of sort of working with the building department to identify what we can do to reduce risk. And then we've also worked with several builders and developers. Doug Terry, there's a development going on right now in Exshaw, Alberta, that is incorporating wildfire protection. And we've also worked with the insurers on the Build Back Better program. So these are existing examples of resilience already applied in Canada. We hope we can draw on for pilots with task force members. So really quickly on what we've done with our insurance membership. So I mentioned our membership represents about 90% of the market in Canada. We approached the CEOs a couple of years ago, and we argued that we have now standards, we have research on resilience for construction, and we think that as part of the rebuild and repair process, that resilience measures should be incorporated into buildings. So we were able to engage 14 fairly large insurers representing about 60% of the market in a working group to mobilize Build Back Better and reconstruction repair after disaster events. We're focusing on some key, what you might call low risk to the insurer, low risk to the builder, high impact measures for our sort of first initial run with our insurance members, and covering our 4 key peril areas, including basement flood, hail, high wind, and wildfire. So as we start talking with the task force and we present the standards, you'll see that they're large documents, 75 pages, et cetera. But we've done work with our insurance membership to identify some key recommendations that can be incorporated, largely right now where supply is available and so on. And that's what we focused on with our insurance membership. And what we've seen over the past couple of years is insurers have developed products or different approaches, largely focused on hail protection in the Calgary area and also basement flood protection across Canada. So that gives us some more practical work to draw on. So which I'll go through. I know there's a lot of content here. I'll try to go through it relatively quickly. We can talk about it over the year. We can talk about anything here for like a whole day. It would be fun for me. But what we'll talk about right now is pilot readiness factors across our 4 key perils. So for ICLR, the most important drivers of loss that we've seen so far in Canada are hail, high winds, wildfire, and basement flood. And we've worked on developing standards and guides with CSA, with Standards Council, with BNQ, with different groups across Canada on all of those topics. But we're at sort of a different stage with respect to the final technical recommendations across these different perils. I've got a set of factors here to help us categorize which areas we could probably work on more quickly than others. So first is, do we understand vulnerability of buildings? Second is, do we understand the protection options that are available? The third one is the technical guidance mature? So are we working with standards that have gone through multiple iterations, or are we dealing with like general guidelines issued by nonprofits? The more developed the standards are, the more ready we are for implementation, we think. Fourth factor is, what degree of risk is assumed by the builder to implement these measures? So, some measures have been applied for many years in Canada, probably are lower risk. Some measures are a bit more novel and might present some risk to builders. The other question is, what can we do on the private property side? So within the building footprint and within the homeowner's own property to mitigate risk. Some of the measures for hail and wind, for example, it all relates to the buildings. For flood and for wildfire, there's considerations off the private property that have to be considered for full resilience. So we'll talk a bit about that as well. The next consideration is maintenance requirements. So once you install those measures, do homeowners have to maintain them? And finally, hazard assessment. Do we know where in Canada, where in communities we should apply these measures? And then one last category is complexity and cost for installation. Is it going to be expensive? Do we have to train tradespeople to be able to install these measures? Those are sort of our initial categories, and noting that we need to work these out with the task force, but this is somewhere to start with the discussion. And then as I go through, I've got some numbers tied to each of these categories. 10 is good, 0 is bad. So first, urban flood. So when we're talking about flooding for ICLR, we tend to focus on urban pluvial flood. And this is a kind of flooding that occurs off of sort of defined river floodplain areas. And it's also not coastal flooding. It's extreme rainfall that overwhelms storm sewer systems, sanitary sewer systems, and causes flooding. Basically, anywhere the rain falls, buildings could potentially flood from pluvial flood. And this is an example from Binbrook in 2012. So this is a development where the 100-year return period 3-hour event would be about 100 millimeters. They had a rainfall event of 250 millimeters over 3 hours. Even very well-designed stormwater systems are not going to prevent flooding during those events. So what can we do at the private property side to reduce risk? One thing I want to point out with this image here is that this is a new development, and the overland flow routes were fairly well defined. Most of the surface water is staying in the street, but under the ground, the wastewater system is overwhelmed and backing up in the buildings, and most of these homes were flooded from sewer backup. So what do we do to mitigate risk? Generally, we apply drainage factors, backwater protection. We apply good practices for foundation drainage systems and sump pump systems. This is all sort of outlined in several new standards that we're involved in developing. Most of the practices are fairly well applied for new construction. For example, I'm sure you're doing good lock rating practices. Most municipalities have lock rating and drainage bylaws that would apply, but there's a lot we can still do a bit more to protect new homes, and we can do a lot to protect existing homes. So going through my criteria, I won't go through everything in detail, but generally we think we're in pretty good shape to conduct pilots in this area. And one of the reasons is that most of the measures are fairly well developed and applied across Canada. As I mentioned before, we're talking about lock rating and drainage, backflow protection, sewer backflow protection, backup power for some pumps. Although the standards are relatively new, so there's some new standards that we worked on, CSA Z800, et cetera. Most municipalities, urban municipalities, have been dealing with this problem for many years and have issued their own guidelines on this topic. So we think we're pretty mature with respect to the technical guidelines. I think the biggest concern for basement flood for somebody working on a specific home is that you can do so much on the private property side, but there's still going to be municipal slide factors that need to be considered for full resilience. And the other thing is, for existing construction, it can get pretty complex. You're dealing with digging up floors, regrading lots, and so on. These are sort of the drawbacks to basement flood protection. But by and large, we've got many examples where we've done this already in Canada. Hey, Frank. Next, wildfires. I'm sure you're familiar with the issues around wildfire. So really quickly, one of the things that we've done at ICLR over the past few years is post-fire community inspections. And so we worked with some researchers on assessing ignitions in Lytton after the fire in 2021. That report's published, but one of their main recommendations was that the fire moved through the community extremely quickly, fast enough that structural fire protection, wildfire protection wouldn't really have made much difference. So we need to apply passive measures on properties within the communities to reduce risk. And I'm sure you're familiar, but I would say we could categorize these protection measures for properties into 2 categories. There's the building measures, and then there's fuel management. Building measures, essentially selection of cladding materials, roof cover, et cetera, that's not vulnerable to ignition. And then fuel management is making sure that the fire is not approaching the building, that we're not storing debris or having juniper bushes that could ignite from embers and so on. This is something that's been going on in BC for many years, and many communities have DPA arrangements for this type of protection, but not widely applied in Canada. This is a complex chart, but really quickly, this is based on an assessment that was done after the Camp Fire in the U.S. A few years ago. That what's presented here is the impact of different building components on ignition risk. So you can see some, and we're talking about measures that comply with wildfire protection recommendations and measures that don't comply with wildfire protection recommendations. Some building elements create more vulnerability to ignition than others. So for example, roof construction, roof cover, that really drives vulnerability of buildings. Structure ignition zone is a very important factor for driving vulnerability. Decks and windows also very important. all of these elements are important, but some drive more vulnerability than others. And so from a pilot perspective, if we're looking to apply, readily accessible measures, low cost measures, our argument is that we could focus on some of these key areas first, and then move on to other elements as money, interest, it becomes available. Also for wildfire, ICLR conducted a benefit cost assessment a few years ago for the NRC wildfire guide. So this gives us a good indication where in Canada we would see a return on the investment for fire protection. So relative to other hazards, we're fairly well set up to identify at least the general areas in Canada that we would benefit from applying wildfire protection.
And just a footnote on that, Cassidy, understanding that that's a dynamic situation.
Right. And so with respect to readiness for piloting, wildfire, as you know, is a little bit more tricky than other hazards because there is the community level consideration. Structured ignition zones extend beyond properties. Fire suppression is going to have a role when there's actually fire coming through an area and so on. But we can still make some difference on the property side. The major concerns I would say is there's maintenance required by homeowners, so we have to engage homeowners, we have to engage communities on ongoing maintenance programs, and sometimes you have to get communities together to manage structured ignition zones and so on. But other areas we're okay, we're well set up, not as well as other hazards. It's still an area of active research, ignition vulnerability of buildings, for example, but we can learn a lot from pilots at this stage. Moving on quickly to high wind, so I'm going to cover high wind and then hail very quickly, and then wrap it up with the overall summary. High wind, we have had a long-running program in Canada, so I mentioned the work with Western University. We're one of the best countries in Canada, in the world when it comes to understanding vulnerability of low-rise buildings to high wind impacts. And so we likely can make some good recommendations, some good pilot applications of measures that address the key drivers of risk in Canada. So what you see in the news, or you see by many commentators, is like buildings that have been completely destroyed by tornadoes, hurricane events, and so on. But when you actually look at damage that occurs during high wind events, you'll see that most of the damage is actually caused to relatively minor damage. You talk about roof cover loss, fascia, siding, downspouts, etc. And that's because the wind field has we have different speeds throughout the wind field. Like right up close to the tornado itself, wind speeds are high. That's where you get those total devastating damages to buildings. But most buildings are affected by the periphery of the tornado track, and that means roof cover and related damages. So we know how to prevent those or how to reduce risk to those types of damage. It's not terribly technically complex. What I'm presenting here is a combination of on-the-ground assessments from the Northern Tornadoes Project team at Western and Xactimate repair data. And so we see that most damage during the 2021 EF2 tornado in Barrie was minor damage, and this minor damage affected about 80% of the buildings that were affected and caused about 55% of the actual reconstruction cost. So the structural damages, they're important from a life safety perspective, but we can do a lot to mitigate physical damage by addressing some of these minor elements of buildings. We also have a benefit cost assessment for high wind protection. Largely, southern parts of Canada would benefit from application of these measures. We're happy to go into detail about that anytime with the task force. So the overall readiness across most of the categories, we're in really good shape. We have good understanding of vulnerability, good understanding of what we can do to reduce vulnerability. We have standards. The standards are relatively new, but they're available right now. They haven't gone through multiple iterations. That would be the only caveat. Protection options, they're all passive. We're talking about more connections, selecting different roof cover, 6 nails instead of 4 for shingles, etc. So not anything that requires maintenance or that would potentially result in significant risk to a builder from our perspective anyway. Hazard assessment is largely available. The one area that might make piloting difficult for existing construction is the structural connections and the structural resistance to high wind, which is very difficult in existing construction, but pretty straightforward in new construction. And then finally, hail. So hail, largely affecting in terms of damages, southern Alberta. We also have a benefit cost assessment conducted for hail impact resistant roof cover. This is UL 2218 class 4 impact resistant roof cover. The additional cost maybe $2,000, $2,500 per home in the Calgary area, but it would pay for itself in about 5 years due to reduced annual damages. We know that most of the damage in hail events is caused to roofs as opposed to other parts of other building components. Very severe events can damage siding and so on, but most damage is caused to roofs. And then we know also that there is impact-resistant roof cover available on the market. Most of the major suppliers have it on hand, especially in Calgary now. So we're thinking this is kind of an ideal candidate for pilots. It's fairly straightforward. The roof cover installation is really no different than standard non-compliant shingles. There's been wide application in Calgary. So the rebate program funded installation of impact-resistant shingles in about 1,600 homes across the city, new and existing homes. So we think a pretty good candidate for piloting. And then just an overall summary. Again, we're trying to get up to the number 80. 80 is like perfect candidate for piloting. Some of our areas are less ideal than others, but we think we can probably make some progress in all of these areas. But notably, high wind and hail seem to be most straightforward. We've got good standards, we've got good guidelines, we've got piloting in place, and also we can make most of the difference at the property side, so in the building itself, and that's a bit different than basement flood and wildland fire. And we have some materials prepared here for the task force when they're interested, when they're ready to think about piloting, that provides information on costing and impact of the different measures. And just to conclude here, saying that this is an initial assessment, we want to work with the task force to refine this information. We're proposing developing a working group to pursue the pilot information. And some, there are additional factors that we could incorporate into our assessment here, like the risk of not incorporating measures, like what's the risk to the homeowners in Calgary if they don't have impact-resistant roof cover. We haven't incorporated that at this stage, but we want to talk to the task force members about these topics. So I'll end it there.